Hi, I am Jillian, a teacher with Jessamine County and Woodford County Adult Education, and I am here again to do another math lesson. Yesterday, I posted a video about simple probability, which is the probability of just one event happening. And we talked about a bunch of different things. So we're going to kind of continue that lesson today with a part 2 for compound probability or some more complex probability questions. So we're going to start by kind of thinking about the models that we used yesterday. So we used a coin toss. I draw a little coin. That's heads. We talked about dice or die yesterday because we just did the one. Just do like that. And we talked about a spinner. We talked about some other things too, but these were our kind of main problems that we talked about. Okay. So let's go through each of these and kind of level up our understanding from simple probability to one level up of compound probability. So compound probability is calculating the probability of more than one event happening. So maybe it's two events happening at the same time or one after another, but it's just more than one event. And in order to find compound probability, we calculate the probability of individual events, just like we did yesterday with our simple probability, same process, but then we multiply those together. So, for example, we'll start with our most basic one, our coin, where we yesterday wanted to calculate the probability of flipping the coin and getting heads. Today, we're going to talk about one level up from that. What is the probability that you would flip the coin, get heads, then flip the coin again and get heads again the second time? So heads 2 times in a row. What's the probability of that? So we would calculate our first probability just like yesterday. Our probability of flipping a coin and getting heads is 1 out of 2. Our 1 is for that measured or desired outcome. 2 is all the possible outcomes. So there's one side with heads on it. There's 2 sides total. So 1 out of 2 is our probability for heads. So now we flip it again. And we're calculating what's the probability for that second flip of getting heads. Well, it's the same. It's the same coin, same probability, 1 out of 2. We multiply these two together. And this is how we find our probability of flipping a coin and getting heads, flipping a coin and getting heads again. We multiply straight across. So it would be 1 times 1 is 1, 2 times 2 is 4. And I'll show you how to do this on the calculator too once we do these 3. But our probability for flipping a coin 2 times in a row and getting heads both times is 1 out of 4, 1/4. On the calculator, if you change that to a percent, that would be 25%, a 25% chance. So it's very similar to calculating your first probability, simple probability like we did yesterday. It's just one extra step with this multiplication. So let's think about our next model, which is the die. If you were rolling a die one time and you were hoping to roll a 6, your probability of rolling a 6 would be 1 out of 6, just like we said yesterday. But what if you were playing a game and you wanted to roll 2 dice and you wanted to roll double 6s? So both dice land on the 6. What's the probability of that happening? So we can calculate that just like we calculated the coin toss. We can say, okay, we have now 2 dice and they're fair, we assume, and we want them both to land on, I'm just going to put some random dots. We want them to both land on 6. So our first die has a 1 in 6 chance of landing on 6. Die number 2 also has a 1 in 6 chance of landing on 6. So we multiply those two together. We end up with 1 over 36, a 1 out of 36 chance for rolling double sixes. Okay? And really, for rolling any two specific numbers, our odds are 1 out of 36. Let me ask one other question, though. Let's say you were playing a game and you wanted to roll a, I don't know, 2. Let's think of a good example. A 6 and an even number. Okay, so let's say that. There's no game where you need that, but we're just going to pretend. So we want our first die to roll a 6 and our second die to roll any even number. It doesn't matter what. Okay, so let's calculate that probability. So our first die, we already did this. It has a 1 in 6 chance of rolling a 6. Your second die, you want to roll an even number. So 2, 4, or 6. There are 3 even numbers on a regular die. So this one would be 3 out of 6. Okay, so we would multiply that across and we would end up with 3 over 36, which could reduce down to 1/12. So it's a little bit different this time because we're calculating two different probabilities, but it's the same process. You calculate your first probability, calculate your second probability, multiply them together, and then you end up with your compound probability, the probability for both of these events. Okay? Let's look at the spinner. So what's the probability of spinning this spinner once and getting a 2 and spinning it the second time and getting a 3? So on spin number 1, we want to get a 2. Spin number 2, we want to get a 3. Okay? So what's the probability for this first event to spin a 2? Well, we have 2 spaces with 2s out of 4 spaces total. So that's 2 out of 4. What's the probability of spinning the 3? We have 1 space with a 3 out of 4 spaces total. So that would be 1 out of 4. So we'll multiply across. We'll have 2. 4 times 4 is 16. And we can reduce that to 1/8. So here's our probability of rolling a 2 and then rolling a 3 would be 1 out of 8. Okay? All right, so this is compound probability where both events are kind of independent of each other. Like you could do this in any order, it wouldn't matter, but you're still doing more than one thing and calculating that probability. So let's kind of take this up to the next level and think about, we're going to go back to another model we did yesterday. We're going to have a little bag of marbles, okay? So let's say in this bag of marbles, we have red marbles and we have blue marbles. Let's see, 4, 5, 6, 7, 8, 9. We'll say 10 marbles in all. 3 are red and 7 are blue. Okay? And let's say I reach my hand into this bag and I want to pull out a red marble. And then I want to put that marble back in the bag, reach in again and pull out another red marble. So this is just like what we did before. In this bag, we have 3 opportunities to pull out a red marble out of 10 total marbles. So our probability would be 3/10, and then we pull that marble out, put it back, shake it up, put our hand in again, pull it out, and we have another 3 in 10 chance. So 9 in 100 chance of pulling out a red marble 2 times in a row if we put the marble back. Now here's kind of the tiny difference that can make a big difference in your problem. let's say we set the problem up a different way. Let's say we said, okay, we want to pull out 2 red marbles, but this time we're going to keep that first marble out. So we want to pull out a red marble and keep it, pull out a second marble and have a red marble again. Okay, so now we have to kind of think about what's the probability this time? How is that going to change things to keep that first marble out? So our first probability is the same. It's the same bag here. It's the same situation with our marbles. So we have 3 red marbles out of 10. So 3 out of 10 is our first probability. But now we've pulled out this, say we took this one, this red marble. Now it's out here. And now we want to reach in and think of what's the probability on this second time we reach in of getting a red marble. Okay, so we can see things in this bag have changed a little bit. Now we only have 2 red marbles. So we have 2 red marbles out of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles left in the bag. 2 of 9. So taking out this first red marble changed things for the second probability. This is called dependent probability, where the second calculation that you're making and all subsequent calculations that you make depend on this first one happening, or they change based on this first one. So let's calculate out this one. So 3 times 2 is 6. 10 times 9 is 90. And I believe that will reduce down to 1. Well, we're just going to do it the old-fashioned way. So I'm going to divide both by 3. So 6 divided by 3 is 2. 90 divided by 3 is 30. We're going to reduce that one more time. 2 divided by 2 is 1. 30 divided by 2 is 15. So 1 out of 15. So our chances are different. Our probability is different based on that one little detail that we changed in the problem, where we put the marble back or we keep the marble out. And this is why with probability problems, half the battle is being able to kind of visualize the problem or draw it out or really understand what they're doing or what they're asking you to do in this problem. So let's do one other scenario here with this bag of marbles. We'll erase that, put the red marble back in. And let's do it with a little bit different this time. Let's say we want to pull out a red marble and a blue marble. Okay, so let's say we want to reach in the bag and get a red marble and then reach in the bag again and pull out a blue marble. What are the odds of that happening, or what's the probability of that? Well, our first calculation is the same. We're getting a red marble first, so we're 3 out of 10 for that first red marble. And now we need to calculate our blue. So we've taken out a red marble. Boop, boop, boop. It's up here now. And now we want to pull out a blue marble. Okay, so what's the probability that now the next one will be blue? Well, we have 1, 2, 3, 4, 5, 6, 7 blues over 9 total. So up here, when we calculated this second probability, both the numerator and the denominator changed because the numerator was still red marbles and we had taken out a red marble. So there was 1 fewer red marbles and 1 fewer marbles overall. This time, since the first one we took out was red, our blue marble count stayed the same. That didn't change at all. Just the overall marble count changed. So again, being able to visualize this problem and understand like, oh, what is left in this bag is really helpful to being able to get this question right. So we're going to multiply across again, and we're going to get 21 out of 90. And again, I'm just going to do this the old-fashioned way and reduce it by hand. So we end up with 7 out of 30. Okay, so a 7 out of 30 chance to pull out a red and then a blue. Okay, all right, let's do some problems that we might see that are maybe a little bit more complex here with compound probability. And we'll kind of practice that close reading that you need to do. So when as I answer these questions, as I go over these, I'm going to write the answer on the screen. And I'm going to talk them all out. But if you would like to, if you feel comfortable with this already, pause the video here, complete these questions, answer them all, and then just skip to the end of the video and you'll be able to see all the answers printed on the screen that we have worked out. So if you're comfortable, do that. If you want to watch the first couple questions while we do those, and then once you feel good about it, pause the video, do the rest on your own, and then skip all my explanations. And then of course, if you have a question on one, you can watch the explanation of that. So let's get started with these. So let's look at number 1. It's a dice question. You roll a single die numbered from 1 to 6 twice. What's the probability of rolling a 6 the first time and an odd number the second? Well, this is very similar to what we did before. We'll keep blue. Okay, so our first die, we want to roll a 6. So we want to roll a 6 with this first one. So we have a 1 in 6 chance of doing that. And then the second one, we want to roll an odd number where there's 3 odd numbers on the dice, 1, 3, and 5. So that would be 3 out of 6, which would come out to be 3 out of 36. And we would reduce that down to 1/12. So this problem, our answer would be 1 out of 12 to get a 6 and then an odd number. Let's look at number 2. Number 2 says a jar contains 12 caramels, 7 mints, and 16 dark chocolates. What is the probability of selecting a dark chocolate and then a caramel? So total in our jar, we have 35 candies. 12 plus 7 plus 16 is 35. So what's the probability of picking a dark chocolate this first time? So there are 16 dark chocolates. So it would be 16 out of 35. Now with this problem, we're not putting that chocolate back. We're gonna eat it. So the second time we reach our hand in, we want to pick out a caramel. Well, the first one we picked out was a chocolate. So there's still 12 caramels. So we have 12 chances to get a caramel, but we ate one of the candies. So there's not 35 in the bag or the jar anymore. Now there's only 34. So we'll multiply this across and then reduce down. I don't even think it reduces. It ends up being 96 over 595. Okay, so 16 over 35 times 12 over 34 gives us 96 over 595. Let's look over at number 3. The numbers 4 through 14 are placed in a bowel. Oh, what a terrible typo that is. It should be bowl and drawn at random, then replaced after being drawn. What's the probability of drawing the number 14 and then a number less than 12? So once again, we are not replacing the number in between. We're just taking one out and keeping it out, taking another one out. So our first number we want is 14. And we have numbers 4 through 14 in the bowl. Oh my God. So there are 11 numbers in this bowl, 4 through 14. So there's only one number 14, so that would be 1 out of 11. And then the next thing we want to pull out is a number less than 12. drawing number 14, and then a number less than 12. So how many numbers are in there that are less than 12? Well, there's 4, 5, 6, 7, 8, 9, 10, and 11. So there are 8 numbers that are left less than 12. But now we don't have 11 numbers in there anymore. We have 10 numbers. So we're going to multiply these two together. And we're going to get 8 over 110. And that can be reduced probably multiple times. So let's see. We'll divide both by 2, and we'll get 4 over 55, and that does not reduce. Thank heavens. So 4 over 55 is our answer for this one. All right, number 4. In a deck of 52 playing cards, what is the probability of drawing a club and then a second club? Okay, so again, we're not replacing. Oh, I just looked at this one and realized that this one was replaced. Let's go back to this last question. Because we did this wrong, or I did this wrong. So, and this is what I'm talking about with close reading with these questions. All right, so this little phrase tells me on this one that after they pull out that first number, they replace it back in the jar. So what's the probability of drawing the number less than 12? It would be 8 over 11, not 8 over 10, because we put that card back. Gosh, I'm glad I caught that. All right, so here we have 8 over 121. Okay, now let's go over here. For this one, we are not replacing the card. We're keeping it out. So in a regular deck of 52 playing cards, there are 13 cards of each suit. So there are 13 chances to pull this first club out of 52 cards. And now you pull out your first card, which is a club. So now there are only 12 clubs left, and there's only 51 cards left. So this is how we would set up this problem. We have 13 clubs to begin with, and then the next time we only have 12. We have 52 cards in total to begin with, and the next time only 51. And our answer reduced is going to be 1 out of 17 for this one. All right, number 5. The letters that form the word Mississippi are placed in a bowl. What is the probability of choosing a vowel, replacing it? Okay, here's our key word here, replacing it, and then drawing a P. So in the word Mississippi, there are 11 letters. And of those 11 letters, how many are a vowel? Well, there's 1, 2, 3, 4 I's. So we'll say 4 over 11. And now you put that I back into the bowl and you pull out another letter and you're hoping for a P this time. Well, there are 2 P's out of 11 letters. So once again, our answer is going to be 8 over 121, just like this one up here. Those are the same. All right, number 6. In a deck of 52 playing cards, what is the probability of drawing a 3 of spades and then a 4 of spades? So in a deck of cards, there's only 1 3 of spades. So 1 out of 52. And there's only 1 4 of spades. But once you've drawn the 3, you only have 51 cards left. Okay, so the odds of drawing the 3 of spades and then the 4 of spades are only 1 in 2,652. They are not good odds. Okay. All right, number 7, you have a jar of jelly beans in front of you with the following flavors. 12 are strawberry, 17 are blueberry, 5 are pineapple, and 13 are coconut. What's the probability of selecting either a strawberry or coconut flavored jelly bean, replacing it, okay, once again, replacing it, and then drawing either a blueberry or pineapple jelly bean. Okay, so for this problem, you have 47 jelly beans in your jar. And your first job is to pick out a strawberry or coconut. So there are 12 strawberries and 13 coconuts. So I'm going to draw this one or write this one over here. There are 25 strawberry and coconuts out of 47 jelly beans. And now you pick one out and then you put it back in. And then you're going to pick another jelly bean out and you want it to be blueberry or pineapple. So how many are blueberries? 17. How many are pineapple? 5. So that gives us 22. And it's still 47 jelly beans because you put that one back. So our final answer is a great big fraction. 550 over 2,209. All right. So 550 over 2209 for that one. All right, number 8. There are 27 students available to represent the upperclassmen at a fair. 13 are juniors and 14 are seniors. What's the probability that the first one chosen will be a senior and the second one will be a junior? So in this case, we're not going to take the senior out and put her back into the group. We're going to take her out and then take another one out and hope it's a junior. So what's the chance that the first one will be a senior? Well, we have 14 seniors out of 27 total students. And then you got your senior. Now you want to reach back in and grab a junior. So we have 13 juniors, but now there's only 26 students left because you took out that senior. So this would give us, once we're all reduced down, 7 over 27 would be our probability here. Number 9, in a deck of 52 playing cards, what is the probability of drawing a card that is a picture card, replacing it, underline that, and then drawing either a heart or a spade? So how many picture cards are there in a deck of cards? Well, there's 4 suits. So there's 4 aces, 4 kings, 4 queens, and 4 jacks. So total there are 16 picture cards. So our first probability is going to be 16 out of 52. So we got our picture card and then we put it back in, we replace it, and then we pick another card. What's the probability that that card will be a heart or a spade? Well, we set up here, there are 13 of each suit. So 26 of the cards, half the cards, are hearts or spades. So 26 out of 52 would be our second probability here. And that would give us a compound probability of 2 over 13 total. All right, number 10, we're getting through them. There are 45 men on the roster of the football team. 3 are quarterbacks, 10 are offensive linemen, 6 are defensive linemen, 4 are running backs, 6 are linebackers, 8 are defensive backs, 1 is a kicker, and the rest are receivers. What is the probability that out of 2 players chosen at random, they would be a quarterback and a receiver? So once again, we're going to pull out one and keep him out and get a second one and keep him out. So what's the probability with this first one that he'll be a quarterback? Well, there are 45 people on the team and 3 are quarterbacks. So that would be 3 out of 45. So now the second one, what's the probability that the second one will be a receiver? There are 35 players listed here, quarterbacks, offensive, defensive linemen, all those guys. There's 35 of those. So the people who are left over are receivers. There are 10 of those. So there are 10 receivers left because we didn't pick any of them, but there are only 44 players left total to pull from now. So our answer here, after we multiply and reduce, would be 1 out of 66. All right, 2 more to go. Number 11. You have a jar of marbles in front of you with the following flavors. It should be colors. 7 are red, 12 are blue, 6 are yellow, and 9 are white. What is the probability of selecting a marble that is not red? So our first one is not red, replacing it, and then one that is white. So there are in our jar 34 total marbles. 7 plus 12 plus 6 plus 9, 34 total marbles. And we want to know, for this first one, what's the probability of not getting a red one? So if 7 are red, that means that 27 are not red. And then our next one, out of 34. Okay, and then our next one we pull out after we replace that one that's not red, we want it to be white. Well, there are 9 white ones out of still 34 since we replaced that one. So this gives us a probability of 243 over 1,156. Kind of a big fraction. All right, number 12. There are 25 men on the roster of the baseball team. 3 are catchers, 8 are infielders, 6 are outfielders, and the remainder are pitchers. What is the probability that out of 2 players chosen at random, they would be a pitcher and an infielder? So on our team, we have 25 players total. 17 of them are listed here in these other positions, which means that the remaining guys who are pitchers, there are only 8 of them. So if we want to pick a pitcher first, there are 8 of those out of the 25 guys on the team. The next one we're going for is an infielder, and we've pulled out our pitcher and kept him out. So now we're looking for an infielder from the guys who are left on the field. And there are 8 of those, but there's only 24 left on the field. So this would give us, all reduced down, 8 over 75. All right. There are plenty of places online that you can practice compound probability. If you Google it, I'm sure you can find some resources, but I'll also link a couple down below this video. I hope that this all made sense to you. If you have questions or comments or anything like that, or if you see a mistake that I made or anything, leave those in the comments below, either on YouTube or on Facebook, and I will get back with you on those. Otherwise, I look forward to seeing you in our next video tomorrow, and I hope you have a great day. Thank you very much.